The elevator is suspended from a massless cord, which is around a frictionless pulley. The elevator is moved by the mass on the other side of the pulley.
Why does that kid look so scared?
One of the passengers seems to have elevator-aphobia. And needs to be reassured. Maybe the force of tension can help us do this.
It doesn't help that I don't know what that is.
So, in order to solve this problem, we need to remember what we've learned about forces. Do we even remember what a force is?
Ooh, I know! A force is an interaction between objects that has the ability to change the motion of an object.
That means the object is accelerating. If one of the objects exerting the force happens to be a rope, a string, a chain, or a cable, we can call that force tension. In this case, the force of tension is the force done on the elevator and its passengers by the massless cord.
Hey, you guys remembered! What forces are being enacted on the elevator and its passengers?
There's the force of tension on the cord and the force of gravity.
All physical objects that are in contact can exert forces on each other. We defined where the force of tension was coming from. How about the other one?
The force of gravity is a force that is equivalent to the object's weight. It is calculated by multiplying the mass of the object by the acceleration due to gravity, which on Earth is 9.81 meters per second squared.
Remember, you can break this force into components to solve more complex problems.
Good job! Now, what is being described in the following situation is a special device used to demonstrate the fundamentals of dynamics and acceleration called an Atwood machine. Typically involving a pulley, a string, and a system of masses, we need to understand a couple of things before we can begin solving the problem. Number one, the force of tension is constant throughout the string. Number two, we need to establish our directions. Let's say the downward direction here is positive. You'll understand soon why this is very important.
So, how do you go about solving these problems? Number one, first you have to determine if the object is moving. Number two, draw a force diagram treating both of the masses and the string as one system. Number three, identify which direction is positive and which is negative. Number four, find the acceleration of the system by summing the external forces outside of the system and equating them to the mass times the acceleration. Number five, draw a force diagram for each individual object and solve for the missing force of tension by using the acceleration solved for previously. 6, be happy to succeed.
First, we have to find the direction that it moves in.
We have to treat the Atwood machine as a system.
What do you mean by system?
We call the sum of the masses a system because the acceleration is the same for each of the individual objects, which means they have to be the same for the entire system. Because we can solve for the acceleration of the system, we will be able to use this later on for individual parts.
This can be done by comparing all the forces in the direction of possible movement, excluding the force of tension, because that is internal to the system.
Wouldn't the first step be to calculate the forces of gravity for each mass?
Yes, here's how.
The force of gravity is equal to mass times the acceleration due to gravity. For the elevator, this is 14,715 newtons, and the force of gravity on the mass is 19,620 newtons.
What does that mean exactly?
This means that if it were to move, it would go in the downward direction for the right side, meaning the elevator would go up.
Now we have to sum the forces on the system by subtracting 14,715 from 19,620 to get 4,905 newtons as the net force. We use Newton's second law.
We know the system mass is 3,500, so we can equate the 4,905 newtons to 3,500 times acceleration. This gives us an acceleration of 1.401 meters per second squared.
Next, let's find the force of tension. We should start this by picking an object to calculate the net force on.
How do you know which object to pick?
We can pick either object because the force of tension is the same on both of the objects. So let's pick this one.
Now to sum the net force on the elevator, that would be the force of tension because it's in the positive direction minus the force of gravity since it's in the negative direction, which is equal to mass times acceleration.
To solve for the force of tension, isolate the variable by adding the force of gravity to the other side, like this.
Now plug in known variables. Now we found that our force of tension is 16,816.5 newtons. Great job, guys! Now we're going to do one more problem with our special guest, Aathira Balu. See if you guys are able to follow that.
For this Atwood machine, two blocks are connected by a string of negligible mass over a massless pulley with friction. One is on a surface and the other is hanging from the string, as shown by the diagram. Your coefficient of static friction is 0.7, and the coefficient of kinetic friction is 0.6. Mass 1 has a mass of 5 kilograms, and mass 2 has a mass of 8 kilograms. First, draw your force diagram for the system. We have to treat both of the masses and the string as the system, because that's how we will eventually find the acceleration. Now we have to find the direction it would move in, if it were to move. Remember, we don't know if it moves yet, because the force of friction could be strong enough to prevent this. You do this by comparing all the forces in the direction of possible movement, excluding the force of friction if it's on a surface, because you don't know what direction the force of friction will apply. The force of gravity on mass 2 is the only force that is acting on the whole system, excluding the force of friction. And this tells us that if the system were to move, it would move in the positive direction. Now you have to determine, will it move in the first place? You take static friction into account here to see if the force of gravity can overcome the maximum force of static friction. You know your coefficient of static friction is 0.7 because it was given, and you can find out your normal force by summing the forces in the y direction for mass 1. This tells us that the normal force is equal to the force of gravity. Solving for the force of gravity, that gives us 49.05 newtons. Our maximum force of static friction is 0.7 times 49.05, which is 34.335 newtons, which is less than our force of gravity. This means that our object will move. Now we have to find our force of kinetic friction so we can actually find the acceleration. Our force of kinetic friction is 0.6 times 49.05 newtons. This gives us 29.43 newtons. Plugging this into our equation, we can solve. The acceleration is 3.773 meters per second squared. Since you have the acceleration for the system, you know the acceleration of the individual objects. In order to solve for the force of tension, you pick one of your objects. Sum the forces for that one object and write your equation. Substitute known values, and then solve for the force of tension. And our force of tension is 48.295 newtons. Thanks for watching!
Wow, I get it now!
Yeah, me too.
Makes sense!
Great!
Thank you, Aathira, for joining our lesson. I hope you all have learned something as well.
Thanks for watching. Bye!
Makes sense!
Some of the fundamentals of okay. An Atwood machine. Just keep going, okay. An Atwood machine, typically involving a pulley, a string, and a system of masses. We need
There's the force of tension by the cord, and there's the
throughout the string. Good job. Now, like don't laugh. I was like.
squared.
Remember, you can break this force.
You know you made a mistake. Then you determine if what is that? It just
Do you want me to
of dynamics and acceleration called
an Atwood machine.
I thought you were gonna draw it.
1,620 to get
sum the net force on the elevator? Mr. Gherkin.